So section 525, day 2 is titled Solving and Applying Quadratic Equations. We're going to be working on page 24 and 25 today. And we're going to answer the question, when can I use it? So question number 109, it says, Karen drives straight south on Interstate 405 from Santa Monica Freeway, interchange going 10 miles per hour faster than Melinda, who leaves the same interchange at the same time going straight east on Interstate 10. After 1 hour, they are 108 miles apart, measured by a single straight line drawn between them. How fast is each driver going? State any assumptions that you make. Okay? So they start at the same spot right here. Karen goes south, Melinda goes east, and Karen is 10 miles faster than Melinda. So we'll call Melinda X, and we'll call Karen X plus 10. And then after, how long does it say? After 1 hour, they're 108 miles apart. So if we were connect them straight across, that would be 108 miles. Okay? So it just so happens that they make a right triangle right there. We're going to solve this by putting it into the Pythagorean Theorem. Why can we do that? We can do that because they make a right triangle. Okay? So this leg squared, which would give us x squared, plus this leg squared, which would give us our x plus 10 squared, is equal to the hypotenuse squared. The hypotenuse is 108. We're going to square it. Then we're going to plug it into the calculator. X squared is x squared. Then we're going to FOIL this out to get x squared plus 20x plus 100. On the right-hand side, I simply did this in my calculator. 108 squared is this really large number, 11,664. And then we're going to set it equal to 0 by subtracting this 11,664. Subtract that from the 100, which gets us minus 11,564. Combine these two x's to get our 2x squared. And then we have our trinomial. So our trinomial is 2x squared plus 20x minus 11,564 equals 0. This is clearly not easily factorable. Okay? So the way we're going to solve this one is we're going to use the Pythagorean Theorem. For the Pythagorean Theorem, we just want to make sure it's in standard form first. Standard form is set equal to 0. And then each of the terms have decreasing exponents. So the x squared, the x to the first, and then the constant term. So it's in standard form. So we simply take the coefficient for each of our a, b, and c. So the coefficient of the x squared is 2. That becomes our a. The coefficient of the x is 20. That becomes our b. And the constant term is negative 11,564. You definitely want a calculator for this, right? So we're going to take those three numbers and plug them in to our quadratic formula. First step, only plug in. Don't try and simplify. Okay? So when we plug it in, we're going to have x equal to the opposite of b, which is 20, plus or minus the square root of b squared, which is 20 squared, minus 4 times a, which is 2, times c, which is negative 11,564, all over 2 times a, which is 2. So that step is just plugging it in. Okay? Get your a in its 2 spots right there and right there. Get your b in the 2 spots right there and right there. And your c just gets plugged in once right there. Then on the next step is when you're going to simplify. So to simplify, you're going to say, this doesn't need to simplify, just rewrite it. Rewrite the plus minus, rewrite the square root, and then underneath is where you're going to plug stuff into your calculator. So 20 squared, you should get 400. Then in your calculator, you're going to multiply negative 4 times 2 times negative 11,564, and you should get plus 92,512. And then in the denominator, 2 times 2 is 4. I didn't do any of that in my head, except for the denominator. I mean, I can multiply 2 times 2. But that I multiplied on my calculator. Okay? That way you make sure you get it right. Then we're going to go back up here to the top and simplify a little bit more. So we have negative 20 plus or minus, and then under that radical, we're going to add those two numbers together to get 92,912. Then we're going to plug each of those into the calculator. So I'm going to do the plus one first. We should have negative 20 plus the square root of 92,912. Hit the equal sign. Divide it by the denominator of 4. And we get this big long decimal. But I'm just going to round it to one number after the decimal. So 71.2, there's a 0 next to it, so it stays. That's our 71.2 answer. Now let's do it with a minus. So for the minus, we're going to have negative 20 minus the square root, 92,912. Hit the equal sign, then divide by the denominator of 4. And again, we get this negative 81.2 rounded. Okay? Now, we got this positive answer of 71.2 and this negative answer of 81.2. When we're talking about how fast somebody's driving a car, does it make sense to have them going negative 81 miles per hour? Is that a possible thing? No. Okay, so we're just in this case, because it's a word problem, and this happens frequently with word problems, if you have a positive and a negative answer, frequently on word problems, the negative answer doesn't make sense. Not always. Sometimes it does. But in this case, it doesn't. So we're going to say that it's not possible to drive negative 81 miles per hour. And so Melinda, who was our X, is driving 71.2 miles per hour. Karen is 10 miles per hour faster, so she's 81.2. Okay? Any questions on problem 109? Okay. Problem 110, we're going to skip. And then go ahead and turn over to the top of page 25. All right. Top of page 25 is question 111. It's called Mo's Yo. Mo is playing with the yo-yo. He throws the yo-yo down and then pulls it back up. The motion of the yo-yo can be roughly modeled by the equation y equals 2x squared minus 4.8x, where x represents the number of seconds since the yo-yo left Mo's hand, and y represents the vertical height in feet of the yo-yo with respect to Mo's hand. Note that when the yo-yo is in Mo's hand, y is equal to 0, and then when the yo-yo is below his hand, y is going to be negative. Okay? So in this case, it would make sense to have a negative answer because it would be below his hand. After I just told you sometimes negative answers don't make sense, but in this one it might. Okay, so for part A, it says how long is Mo's yo-yo out of his hand? So we're going to take the equation y equals 2x squared minus 4.8x, and we're going to set it equal to 0, mostly because it tells us to in the problem, and then we're going to see if we can factor anything out. When I look at the coefficient here, and here I noticed that they're both even, and so I factored out a 2. When you factor out a 2, that leaves you with x squared minus 2.4x. Then we can also factor out an x, which leaves us with x minus 2.4. And then we can solve for each of them, okay? So if we take the factor 2x and set it equal to 0, divide both sides by 2, we still get 0. If we take the factor x minus 2.4, set it equal to 0, add 2.4 to each side, we get x equals 2.4 seconds. So what does that mean for the yo-yo, right? The yo-yo's in his hand. I don't know if you guys have ever seen a yo-yo before, right? But you fling it down. It hits the bottom, then what does it do? Comes back up, comes back in your hand. So it's in the hand at 0, it goes down, comes back up, and back in the hand at 2.4. Does that make sense? 0, 2.4. Okay? All right, part B says once the yo-yo leaves Mo's hand, how long does it take for the yo-yo to turn around? That is, to start its return to his hand. Use what you know about parabolas to help. Okay? So if it's the yo-yo's here in his hand, it goes down. Right there is where we want to know when's it going to turn around. That should be roughly what of this? From 2.4, where it comes back up and lands in the hand. So 0, where is it hitting the bottom? What did you say? No, 2.4 is when it's back in the hand. 1.2. How did he get 1.2? It's half of it, okay? So you're going to take the 2.4, divide it by 2, and at 1.2 seconds, it's going to be halfway, right? Here, the farthest most point at the bottom, and then back up, okay? Because parabolas are symmetrical, right? So exactly halfway is where it's going to be the bottom, okay? So part C says, how long is the yo-yo string? Assume that all the string has been let out when the yo-yo changes direction, okay? So at 1.2, we want to know how long is it. So we're going to plug in the 1.2 in for x here and in for x here. Back into that original equation we had back up at the top. Then we're going to use our calculator, right? So we're going to take 1.2 and square it. You get 1.44. Then we're going to multiply 4.8 times 1.2. And we're going to get 5.76. Then we're going to multiply this out. 2 times 1.44 is 2.88. Subtract the 5.76. And we actually get a negative answer. If you take 2.88 minus the 5.76, you get negative 2.88. So this one does have a negative answer because it's going down, right? You want to know what that lowest point is. Yo-yo drops out of hand, you want to know where it's at down here, okay? So it's down 2.88. So that string is roughly 2.88 feet long. And then part D, they want us to sketch a graph representing the motion of Mo's yo-yo. On the sketch, label the important points. When the yo-yo is in Mo's hand and when it changes direction, okay? So here the yo-yo is in Mo's hand. He drops it down.